Hi everyone, so let me start this tutorial on SAS EG and running the ARIMA model in it. Let me just locate SAS EG on my computer. Here we go. Perfect. So I'm gonna create a new project and I don't need this. So let me just create a new project. Actually, I'm not gonna save it later. So I will start with running a libname statement. Libname bst477, and I'm going to show to SAS where I would like to save the data in the process of my work with it. I have it on my C drive. I created a folder called data, but I mean guys, like you can actually do it anywhere. I'm pressing now Fn F3, flight mode, okay. So just F3, sorry. And yeah, so let me check if the library was created. Yes, perfect. Okay, so today we are going to do a ARIMA model. For that we definitely need to import some data, and we are going to be doing Amtrak writes, and I have my data here on C drive. Let me just get here, drive C, data, and it's a CSV file. That's what I'm gonna import. I am creating right now a temporary file because later I will create a permanent time series file from it. So next, I only have 2 columns, month, ridership. There is no need for me to rename columns to comply with the SAS naming conventions, but you know, you can always do it. We only have 2 columns, as I mentioned. So if you have, let's say, a column name where you have some space, go for this option. Like for this file, I don't need it. Next, done. So finish, and we have this file that has 150 observations in total, and it's actually monthly data collected starting from the 1st of January 1991, and on the first day of every month they would collect some data, and they would show how many rides in thousands there were per month, how many of them were done by Amtrak. So to actually start our analysis, we will go to Analyze, Time Series, and we'll start with the first basic step, prepare time series data. So we'll go here, and I'm not going to include the month variable. Instead, I will actually put here new time ID. I will rename it. I will say, for example, something like a year, because it's not, I mean, it's like, okay, maybe not year, date, whatever. So we have the interval monthly, which is correct, but we need to change now when the data collection started. So I'll start here, 1991, as I said, the 1st of January. So it will always be the first month, the first day of the month. So this is the time ID. Now we need to find the variable we're going to analyze. I'm going to just include this one here. Say always replace existing variable ridership. It's gonna overwrite it. So this is a creation of a new data set. So we do not need anything else except for the results. So what I would like to do, I would actually like to save this data into our library that we created. So to do that, I click on Browse in the results, as I said, then Servers, Local, bst477, and I will call it Amtrak full, because for time series analysis we definitely need to create train and validation data sets. So now I will run, and voila, so I have here my data. And you know, to start actually our analysis, let's go first of all, before we'll exploit the data set, before we partition it, before we do stuff, let's go with the line plot, okay? So we can choose either line plot wizard or line plot. Let's go for line plot wizard, it's faster. So next, ridership is horizontal, vertical is date. It's actually, it should be the other way around, so date and ridership. I'm not going to change anything, I'll just go by default. So that will be our ridership that is available. So as we can see, it seems that there is some trend going on. And we can also observe a little bit of heteroscedasticity in the data, because sometimes we see that the amplitude is changing, and that may mean that the data is a little bit heteroscedastic, but it's not it's not apparent, so it's possible that the variance is changing. So this is our plot right now, and we could definitely analyze it further. But what I wanted to show to you is, before we even start, that we have to filter and sort this data to actually to be able to analyze them, like build the model first, and then verify it, validate it on the other part of the data set that we will keep for later. So we have we are going to partition the data this way. So we will keep 3 years of data to continue our analysis. So we will start at observation 1, January 91, and we will finish at March 2001. So we will include 123 observations into our training data set, and the rest will go into our validation data set. Pretty much like in SAS right now, we do not have to worry about creating both. We can only create the train, and then we'll continue our work in Excel. So filter and sort, that's where we have to go. So this is our new data set. Let me just put this here. And now let me just go to filter and say that date is less than or equal to, for example. And now we have to select equal to what. And as we specified, it was 2001. It was March 2001. Perfect. So we do not sort anything, but I would like my results to be recorded not in the work library, but in our library BSTA 477, sorry. So instead of calling it filter from truck, I will call it train on truck. It's kind of weird, I mean, because on truck is a train, right? I mean, yeah. So anyway, so I will, by train I mean the training data set. So that's all we have. Let me check if the split was done correctly. We should have 123 observations. Perfect, yeah. So we have exactly what we need. And now we are ready to start our analysis. So before that, let me just show to you something. So when we are working with the ARIMA model, we have to know what model we should run, because ARIMA has 3 parts, right? The ARIMA has the AR component. It has also the integrated component, which is differencing, and also it has the moving average component. So if you see the autocorrelation plot and the partial autocorrelation plot like this, that means that perhaps you have the AR, like you will actually have to use the AR component for sure, because this is a great indication that there is an AR process going on. So here you will see like a slow subsiding of the autocorrelations for many lags. And here you will see like a few spikes above the boundaries, and then you will not see any more, So this is the AR process. If you see the opposite, the reverse process, if you see like just maybe 1 or 2 spikes here for the ACF plot or autocorrelation plot, and if you see a slow subsiding of the autocorrelations in the partial autocorrelations, so that can be a great indicator that you have an MA process going on. You will also see a lot of graphs that are not really indicative. Let me show you a few more examples. So, for example, a plot like this, it's not really straightforward. So this is a great indicator of the AR process going on, because you see like the spikes slowly subside, so the autocorrelation slowly subside. They also indicate that there is a trend in your data. And if you see some strong spikes at some points, you may need to look maybe for seasonality. Like here, for example, we see like a spike at a lag of 12, then there is one at a lag of 24. So perhaps we're dealing here with the annual data, and with monthly data, and the seasonality equals 12 here. So that's really possible. The next one is here. So here as well, this is the partial autocorrelation. Because we do not see, that actually, like, we see here only 3 lags, right? The partial autocorrelations at 3 lags. And it's possible that we are still dealing here with the AR process, but again, we see spikes at a lag of 12 and at a lag of 24. It can be like a confirmation that there is a seasonality of 12. So every January, let's say that sales of January in one year are related or correlated with the sales of January in another year. Here again, it's really difficult to say what kind of process you're dealing with here. Perhaps both. Here you see like a super strong trend up to like 16 and maybe more, and this is definitely an AR process going on, but you also see a few lags, up to like 6, and even at 7 you see some spike. So it's possible that also you have an MA process going on, and the same for the Wilson bridge data. They're actually pretty similar. Here it's possible that you have some AR process going on, no MA process, no partial autocorrelations. And here again, like you see some AR process going on, and a few spikes here and then here, so perhaps you do not have any MA process, or maybe you do, like you don't know, this is like the first step in analyzing and estimating your data. So let's go and let's see what we have here. So this is our training data set. And to work with ARIMA, you should know, like before we saw a graph here, that our data is not stationary. So if you have a trend, the data is not stationary, and this is bad for ARIMA. Like ARIMA, especially the MA process, it's very sensitive to non-stationary data. You will not have an accurate forecast, so that's why we definitely have to come back and fix it somehow. So what we're going to do, first of all, we're going to go back to our data set, and we're going to apply a few processes. We'll start with the first one, like with the simplest model, and then we'll move on to more complicated models. ARIMA modeling and forecasting, that's where you should go. So analyze, time series, ARIMA modeling and forecasting. I mean, this is pretty straightforward, right? You open it. And we are dealing with the time series variable, and our date is the variable that we created when we were creating the time ID, and this is our new time ID variable. We have here a few options, right? So this is the I component of the ARIMA model. So if you want to difference it, then you will click here and you will difference it, right? So then we can also do some stationarity tests. And we can see some plots, like I would actually like to see the actual values plot. If you want to save some autocorrelations in the dataset, go ahead, you can do it here. Then we have the estimation. So at the estimation part, you have to activate it here. Enable estimation steps. You have to check it. Then you can go to the model definition. And here exactly you will be identifying your AR and your MA orders. So you can actually just do it here. We are going to start with the AR process. I'm just doing it, at random right now, but we are going to see the plots and we are going to see if it was a good idea or not. So add model option. If you want to drop mean term for model, usually if you difference the data, you will drop it. If you don't have to. Then results, like I really like to save parameter estimates because that's where you get your coefficients. And if you go to forecasting, you will go to enable forecasting steps, because this is our validation set that we are going to forecast right now. So then you will go to options, and we want to predict monthly observations. I mean, this is like the interval between observations is monthly. And we want to forecast 36 periods because it's 3 years. So that's what we have to forecast, and our confidence level, we will set it to 95%. So what we're going to get as an output, it will be our point forecast, but we'll also have the boundaries, lower and the upper forecast. So the boundaries of the forecast within which we can approximately assume that our rights will be at that point, at that level. Now plots and results, we want the forecast, we want the residuals. It's really useful. And we would like to save forecasts for sure, because then you can actually export that file in Excel and then you can use it. So this is all you have to do. So again, you start with the data here, like you have to say what you're trying to forecast, which is ridership. You can create a time ID variable from scratch. You don't even need to have it, but you need to have time series data even without the timestamp. It's not a big deal, you can create it from scratch. Then if you feel that you need to difference your data, usually if you have your trend and seasonality, you will definitely want to go that way. But right now we are not doing it. We are going to return, and then we're going to change our model a little bit later. If you want to do some stationarity tests, you're welcome to do that. And actually we are going to do them later, a little bit later. And yes, also enable estimation steps. Again, define your model using ARIMA. And yes, and also what is important, perform forecasting steps, go to options, specify what is your forecast horizon, and also the intervals of your data, and ask it to save the forecast for you so that you could actually see the forecast. You can also click on suppress displayed forecasting output because you perhaps don't need it, or you can keep it. So we'll do both so that you could see the difference. Okay, so let's run. Perfect. So we can see actually what we have here. So we have here the autocorrelation check for white noise. So here we can see if there are any autocorrelations, like serious autocorrelations, serial autocorrelations up to lag 24, and because the p-value is very low, it tells us that yes, there are some autocorrelations. So here we have our actual data plotted in this cute tiny graph. Then we have the autocorrelations and the partial autocorrelations. And if we check, so these are just autocorrelations of the values, like actual values. And you can see, so we have a strong correlation at lag of 0, which is so normal. It's totally normal because actually you would expect the one period to be perfectly correlated with itself. So it's a correlation of 1. Then you see that there is another correlation here, then there is another spike here. So everything that is beyond this blue area is considered to be highly correlated. So you can see it at lag of 1, which is okay. Again, it's okay. It's not a big deal if like lag of 1 is correlated, because in time series we expect our values to be correlated with each other. You expect that the price of a car tomorrow is correlated with the price of a car yesterday or last month. So that's perfectly normal. And then we have a correlation at spike of 4, at a spike of 4, at a spike of 6, at a spike of, and there is a strong spike at a lag of 12, which may be an indicator of some seasonality that is going on in the data. And there is a spike of, there is another spike at a lag of, I don't know, maybe like 16, 17, 18 maybe, and another spike at the lag of 24 again. So 12, 24, so perhaps we have some seasonality. Then if you look at the partial autocorrelations, you will see a spike at a leg of 6, then 7, of course 0, also 12, and also 24 we don't have any spike here, but again, we will check, we will also identify which one was best. So what it tells you, that perhaps we have some MA process going on, because here we do not have, you know, like a lot of strong correlations that you would expect to see when you run like an NAR process. And here you have, but on the other hand, here you have like more correlations, but again, they're not also as strong. So perhaps we have both processes going on, perhaps we only have like an MA process going on. But again, as I said, MA processes don't like to have a trend, they don't like to have a non-stationary data, they want the data differenced, they want it to be correlated around 0. So here's our most important output, you know, that we would need to see. So one of them is the mean, and the mean is estimated to be at 1,772.9. And when you include this mean into your model, you will have to multiply it by 1 minus the sum of all AR coefficients. And also we have the AR coefficient 0.44667. We didn't do any differencing, so you will just multiply it, and that's it. You will multiply it by the original value, previous value, and that's it. So like a 1. So after we ran the model, we have residual correlations. So before we had you know, regular correlations, right? And here we have correlations of residuals, and you can see that the autocorrelation plot shows to us that there is a strong spike at a leg of 6, a leg of 12, a leg of I don't know, maybe 18, a leg of 24. Yeah, there is a spike at a leg of 6, and another one at a leg of maybe 12-ish, I don't know. And also the white noise probabilities, they show to you, so everything that is beyond this line, like that is not underneath this line, shows to you that the legs are strongly correlated. I mean, the residuals, actually, the residuals are strongly correlated, and this is bad because you want your residuals to be independent. So that, what it tells you, first of all, like when you see a graph like this, that your model is not really good because your residuals are correlated, so that means that you will not really be able to create accurate forecasts. They will be biased. So are they normally distributed? They seem to be normalish, let's put it this way. And you have this QQ plot where you can also see that the residuals are pretty normal, but I mean, they're not perfect, definitely. They're not like following this line, but still they're not as bad, right? And so this is like our actual values, and this is our residuals, and you can see that some of them exceed 300. So sometimes we miss it by 300 writes, or 300,000 writes actually. So that's maybe not perfectly accurate. So now knowing, now seeing this graph, these graphs actually, we can try to apply different things. But before that, what I would like to do, I just wanted to show to you what output you get. So if you go to the output data, you get this output where you have your mean, you have your AR coefficient, you also have like your standard deviation, and this is one, and the other one is forecasts. So you will have forecasts for your riderships, and as I said, you have also the boundaries, lower and upper boundaries, and residual. So this is like prediction interval, right? Lower, upper. And you also have residuals, you also have the standard deviation, and like point forecasts are here, and the actual data is here. So if you go low, you could see that we do not have the validation dataset data, but we still have like the forecasts. So if you want to copy this data, what you can do, you can just press Ctrl A and then right click and say copy with headers, and then place it all into an Excel file. And now in your Excel file, you will have your data set, right? And I just wanted to show to you how the AR works, like, you know, by trying to replicate the forecasts created by SAS. So now I'm going to copy this parameter estimates, copy with headers. This is like the easiest, the simplest model, right? So it's going to be not so hard. Let me just make these, sorry, let me just make them bold. And I would actually like to freeze the first two rows. I'm not sure if you can do it in Windows, but let me try. So freeze panes, freeze top row, only top row. Let me see. Can I freeze both? Okay, yeah, so I will freeze them up to now. So I'm going to create an extra column. I will call it forecast calc, so that you know, because when you have to create your own forecasts, you can actually, you can do it by yourself, given the coefficients. Forecast calc, so this is calculated forecast. And I really encourage you to try to do it, because ARIMA models, you know, if it's a simple model, then it's not a big deal. But sometimes, like you will see, actually will run a more difficult model. So in that case, actually, what you will have is that you may have a more complicated version, and you know, then you will have really to know what to do with these coefficients that you got. So for the first forecast, this is very simple. All you have to do is just to create a forecast that will be equal to your mean. So the first forecast equals to the mean. That's all. That's how you set it. Like if I click here, you will see that it's accurate up to the decimal points, all different decimal points that we have here. So now this is like the beginning only. So now for the next forecast, the formula will be your mean plus AR multiplied by the previous value. That's all. So your mean multiplied by 1 minus AR, so that's gonna always be like this. And if you have multiple ARs, you will have to if you have the mean, so it will be mean multiplied by 1 minus AR minus another AR, and so on. So you know, like all of the coefficients, 1 minus as many ARs as you have, plus AR multiplied by the leg of 1, so the previous value. And that's how you get it. So now if I just freeze these, because I cannot move, you know, the AR or the mean, then I'm gonna just create the same thing for everything. I have hopefully accurate forecasts. Okay, let me just unfreeze them, maybe unfreeze panes. Okay, so they should be the same. And but here we see a value, you know, so we cannot replicate the forecast, because right now we don't have this option of multiplying it by the actual value. We don't have it, so we'll have to go with the forecast that we created. So in this case, here it was B124. Now it will be instead of B125, it will be C124. Oh, sorry, C1, 25, yeah, sorry. I just went too far. Okay, yes, and we're going to use the C instead everywhere. So this is our ARIMA. If we speak about notation, ARIMA, it will be ARIMA 1, 0, 0. We don't have any seasonality here, we have nothing. Again, I'm trying to save it, but I will just save it later. Nothing else. So this is the simplest model that you can get. So let's move on, and let's continue, you know, working with the data. I'm gonna click on modify task, because I do not want to start from scratch, but I can say here what model I created. So it will be ARIMA 1, 0, 0. And that's it. So now this is, like we saw, it's not the perfect model, so definitely we have to keep moving, right? So now what I'm going to do, I'm going to difference it once, and it will be ARIMA 1, 1. So difference it once. We can also ask I don't know, let's say for example here you can ask for autoregressive orders up to 24, and everything else will keep the same. So AR will stay at 1. Again, this is a very simple model. You don't want to go, you know, all the way right away, like to the seasonal model or something. You want to try to play with the simple models first. Oh, I think I just did something that I wasn't intending to do, but it's okay. Okay, so let's wait. Oh, I think actually that it created the output. So now we have all of those lags. If you want to see them, you will see them here. So it tells you about different correlations. We saw these graphs before. Now our coefficient is different, and the mean is different as well. And it's all because we differenced the data. So right now, if you look here, you will see a different graph here. You will see also that we have a lot of spikes. So now we can see, because we removed the trend, we can pretty much see our seasonality. And you can see that, like, it's pretty obvious, right? 6 and then 12 and then 18 and then 24, right? So here it's again 6 and then 12 and 24, 22 maybe, I don't know. At 24 we don't have any lag, I guess, here in the partial correlations. The residuals look bad again, normalish but bad. So we do not have, yes, and also what is interesting, yes, in this graph we can see that after the differencing, now our data looks more or less stationary. It doesn't, you know, show any trend, and it pretty much, you know, fluctuates around 0, which is good. So now again, let me show what we have. We have our output data, and let's just try to build the ARIMA model in our Excel file to see how actually the model works if you do differencing. Okay, so copy with headers, and I'm gonna include it here. So let me just write what ARIMA model we are building now, and it's ARIMA 110. And again, we don't know if it's good or not, you know, like with ARIMA, unfortunately, the best way definitely is to run an automatic model, because you know, you can try to predict stuff, but very often it won't be as efficient, and perhaps it can be even worse than if you ask some algorithm to calculate it for you, because an ARIMA model is an iterative model, and it makes sense, you know, when you have it, like you cannot do it by yourself because it's gonna be like a really long process. So the best way is definitely to do it, you know, using some R, for example, packages, and that's gonna help a lot. Okay, so right now what you can see is this. We are running this ARIMA model. So if you're doing differencing, the thing that happens is that you will lose your first observation. So our first observation is non-existent. And now if you see, our forecast is different from the lag of 1. But it's different because we have actually just to add the mean to this lag, and now we have exactly the same forecast. And this is our first value here. Okay, so this is of course not the complete formula, and to create the complete formula we definitely have to go you know, all the way like with the mean. And as you remember, we'll start with the mean because this is our intercept pretty much, and we'll multiply it by 1 minus the ARIMA coefficient, the AR coefficient, sorry. And now we will also have plus, but the thing is, because we use the differencing, right? That means actually that we have to apply this AR coefficient to differenced to the difference data. So we will have to lag it because we cannot have, you know, to predict March you cannot have the March data. You can only have like February and January data, right? So we will have to go like at a lag of 1, but we have to difference that lag of 1 time. So it will be February minus January multiplied by AR plus, because this is a leg of one model, we have to add the February data. And now we have this information, so let me just freeze these values so that they don't move. We cannot move our values. And now we have this forecast. It's a point forecast. We're not going to go into the prediction interval, but still it's kind of nice to know how it works, right? So now again, here we have this B124. Here we do not have B125 anymore, the actual value. So we have to go with the C. Like, this is the only option that we have available. Sorry. So we have to go with the C here and here. And at some point, we will still see that we do not have, yes, okay, so here now we do not have our B125 anymore, and that's the last one. Okay, so now I can just apply it, and we have our forecasts for the future. Perfect, so this is ARIMA 110. Now let me move on, and now let's try to build a different model. So actually, I made a mistake when I didn't save it. So I will just rename this one into ARIMA 11. Okay, so now let's also create. Let's add the MA process to this model. Okay, so I'm going to we still definitely have to move forward because the residuals still show correlations, and that's bad. And if you see this white noise probability, so they're strongly correlated, and you don't want that to happen. Or you can also see it here in this output, that our p-value even at lag of 24 is much less than than alpha equals 0.05. So that's not the best thing that can happen. Now modify task, and again we have ridership date. We will still stick to difference in the 1 for now. So no seasonality yet, but we are going to include in the model definition, we're going to include also the MA factor. Okay, so this is all the rest stays the same. We will run it, but instead of doing what I did before, we're going to say no. So what we mean is create a new model. Don't overwrite the one we ran before. So let me just change it so that we don't forget what we created. So it will be ARIMA 111. Okay, let me just do it here. ARIMA 111, perfect. So now we have our correlations. Again, they are correlated, we knew about that. So the difference data stayed the same graphs, but now we have an extra coefficient and an NMA coefficient. And we still have our mean, so we're going to go with the mean so far. And yes, so we have all of this information. Now we can see again that we still have these correlations, the autocorrelations and the partial correlations are still present. The residuals are still not normal, they're still strongly correlated. So all of this means that the model is not perfect. We also have the information how many differences were there. And let's go to the output data and let's check out in Excel how it worked. So what is the formula or the equation actually used? So Control A, copy with headers. And now this is ARIMA 111 model. And let me just include this. We'll create after this another one, and that will be it. So just 4 models just to give you the feel of the data, the feel of how it works, because I'm going to show you the best model. We're not checking yet any estimators, like any AIC, BIC. You can do them for sure, and you should do that. But my goal now is just to show how it all works. So let me just create an extra column, forecast calculated. And so again, we're going to set our first value. Since we did the difference in the 1, we're going just to skip it, it's lost, right? And the setup value will be equal to this plus So this is identical to what we have in our forecast. So there is nothing special here. But now the formula is going to be a lot more complex than what we saw before. So what is going to happen is the beginning will be as what we saw before. So mu multiplied by 1 minus the AR component. After that, we will have again our difference data, right? So it will be February minus January and multiplied by our AR, right? So this is what we saw before. But now we are going to see something really interesting. So if you remember the MA processes, they get built of the errors. And now, because we had this value as our setup value, we are going to have our error of like 1, because it's, we chose MA1. So we will have to use the error for February to subtract it from March. So we'll say minus, and now we have to calculate the error, the actual value minus the forecasted value. We actually could have just used this residual multiplied by our MA coefficient and plus leg of 1. So this is the formula. So again, you calculate the intercept. The intercept will be pretty much the mean multiplied by 1 minus AR. And then you have to also include there your B3, so the previous value, leg of 1. And then multiply the difference value of February minus January, right, by AR, and subtract the error weighted by the MA1 coefficient. So this is our forecast, and as you can see, it coincides with what we saw, with what SAS created. So this, let me also check out, let me continue, and let me see what else we have to freeze here. Yeah, so we are freezing this. And again, guys, now I'm gonna just create all the forecasts, but at some point we'll have just to tweak our model a little bit. So as soon as we run out of the actual values, we have to go for the forecasted values and build our forecasts of those values. So pretty much like we will not need this anymore, so we'll not have any error per se, right? Because there is no error for us to calculate anymore. We can just delete it, but I'm gonna keep it, so pretty much it will be like 0 multiplied by the error term, and plus, now it's not B but it's C. So that's what we have, and let me just see if I have to delete anything else. Yeah, okay, so now we will have also here C125, and that's pretty much it. So now we are done with all these forecasts. Okay, so this was, again, I'm trying to save it, but I don't want to save it yet. So all of this was actually pretty simple, but you see how more and more complex the model gets, right? So you have to take into account one leg, so the previous value. Then you kind of add to that value the level. So this is your mu multiplied by 1 minus AR coefficient. Then you also have to add to that leg of 1 difference data multiplied by the AR1 coefficient, and you have to subtract the the error, the residual of the previous period, multiplied by the MA coefficient, and that's how you get your forecasts. Are they good? I mean, it depends. We saw that the model is not perfect yet, so guys, now we are going to go for a very, very complex model, one of the most complex. I will click on modify task. So now what we are going to do, we are going to take into account what we already saw. We're going to difference it twice. So we'll difference it at leg of 1 to remove the trend, which we did successfully. Plus we'll difference it at the leg of 12 to remove the seasonality. Then stationarity tests, we don't have to worry about them. We could also, like, we don't actually even need to perform this stationarity test. We saw them many times. So yes, now enable estimation tests. So we have like this factor for AR model, we can remove this 1 and we can do 1, 12. So this is the model we're going to be creating. We will create the model that will be, I will show you like a little bit later. So more options. Okay, let's drop the mean term from the model. Because you know, we are differencing the data, but if you don't drop, you know what to do, so you know how to go about it. And so now let's continue and let's do it. So give me just 1 second. Okay, so the next one, results. We want to save parameter estimates. Also, we could actually save diagnostic statistics. Yeah, I forgot to tell you about this. So when you save it, you will also see some array terms for the training data set. Enable forecasting steps, everything stays the same. There is nothing new. Say forecasts, we don't want to see the output. That's it. When we say run, we will say no. So now this is a seasonal ARIMA, SARIMA. This is ARIMA model. So it will have actually a few components. So the first part will be 1, 1, 1, so P equals 1, D equals 1, Q equals 1. And then you will have the other part will be 0, because we do not do any AR at a seasonality of 12, then 1 and 1. So, and 12. So this is our ARIMA model. It's ARIMA, it's seasonal ARIMA with a seasonality of 12. And let's see what we have here. So let's go right away to check the residuals. Now you see they are normal. Now you can see that the correlations are absent. Now you can also see in these plots that we have no spikes anymore. And even here we can see that our p-value is greater than 0.05, even for a lag of 6. And you know, if you look further, the correlations subside. So this is perfect. So we do not have any strong correlations. We actually have like super tiny correlations, which is great. And that's exactly what a good model looks like. But the model is going to be complex, and let's see what happens. So let me also show to you the diagnostic statistics. So this is what you have. You have your AIC, then also the Bayesian criterion, information criterion, SSC. You don't have much, but still you have some parameters. You can also calculate them using Excel. So let's go to forecasts, and you can see that because this is seasonal model, that actually that means that you lose 12 points of your data. So you lose a year of your observations. And you know, if you do not have enough, that means that you actually should maybe avoid using ARIMA, just because you know you will not have enough data to build a really good model. So let me just copy all of these parameters that you need to use. So you can see now that we have, oh, I forgot to copy them with headers. Let me just redo it, because without headers it's like really difficult to understand what we're dealing with. Perfect. Okay, let me just make them bold. And again, I'm gonna add a new column here, calculated. So this model is going to be super complex. So right now we don't have any mean. If we had it, we would have used the same principles we used before. It would be again your mean multiplied by 1 minus 1 by 1 minus the AR component. Right now we do not have to worry about it. So what we have to do is this. Our current setup point will equal to the previous point plus the difference between February and January. So that's how actually. So this is the difference of lag of 1, but also it's like seasonal, right? So we will take January, and then you will have, and we're trying to forecast February, so we will have to include February minus January here as well. So the seasonal difference between February and January. You're basically removing the January observation, the January portion from February, and you're adding it to February of this year, of the next year, something like that. So this is our setup point, and that's where we are going to take our error terms for the MA But what is interesting right now, you can see that we will need the array terms of leg of 1 and leg of 12. And the AR component will also need, the formula is going to be more complex because the seasonality will be included at every step of the model. So right now, since we do not have any mean, we have our March forecast will equal to February plus, again, differenced March and February from the past. So March minus February. I'm just putting them in brackets so that you could understand what we are doing. We are just removing February from March, pretty much, okay? And we will add what is left from March from the previous year. We will add it to our February to get March of the next year. So that's the first thing. And now we will add our AR component, which is going to be really complex. So we will have here two portions. Portion number 1 is a leg of 1, so you will have to, because we did differencing, we have to difference February and January, right? But also we have a seasonal component, so you have to subtract from it your February and January from the last year, and now you can multiply it by your AR. So that's one part. And also we have to definitely subtract the error from the previous period, leg of 1. We do not have leg of 12 yet, we are going to get there. But right now we will just, or you could just use this residual. I'm just showing to you like the full model possible, and we'll multiply it by the first MA. Okay, so now this is what we have. And again, if I just click here, you will see that we have a full, identical forecasts. So we can use this, let me just freeze the most important parts here, and then we'll move on. So here for now we just have, we didn't use MA of 12 because we do not have any errors yet. Right now they are all equal to 0, so that's why. Up to January we'll get forecasts, but then we will not get any accurate forecasts anymore because now we have to include the MA of 12 coefficient into our formula as well. So you see right now the formula is complex already, but now we have actually to use more stuff to reach the full model. So what we do is this. Again, the formula is going to be identical to what we have, but we will also have to include the difference data for the difference between the previous period of month of 12. So give me just 1 second. So again, it will be, the beginning will be the same between you. So it will be, to forecast February, we need to include January plus the difference between February and January from the previous year, which is okay. So now we will also have to include the same AR coefficient as before. That doesn't change. But we will also need to exclude our coefficient of leg of 12. So minus. That's what I'm gonna add now. Minus. I will actually, I will add it later, after the leg of 1. So minus, and we have to go all the way to the previous February. So it will be February minus one second, is it even correct? No, sorry, it has to be March. So it will be March minus February. So we will have to include into account the error term from March multiplied by now the multiply now by the error term, the MA12 coefficient, and now we'll have to add the error from the previous period, so from the period before March, so that we kind of, you know, take into account that error as well, and we will multiply it by both coefficients, MA1 and MA2. There's just, this formula is really, it's long. Hopefully I will get it right. And again, no, I didn't get it right. So let me check where was the mistake. So we will have to, okay, the forecast March, B26 plus B15 minus B14, that's good, plus B26 minus B25 minus B15 minus B13 multiplied by the AR component, and then minus B26 minus C26 by M2 minus B15. Okay, so I see now. Yeah, sorry, it will be B15. Okay, yeah, that's where I actually didn't do it right. We will add that component later. Okay, yes. So now we only had 12 errors. Yes, so it will be February. True, because we are forecasting February now. Somehow I thought we were forecasting March. Okay, so to forecast March, we'll do pretty much the same thing. So we'll take the previous period into account, and again plus the seasonal difference between March and February, March minus February from the past year, and actually now it's gonna get more complex. So plus, and again we'll do this B26 minus B27 minus B26 minus this difference B15 minus B14, and we'll multiply it by our AR coefficient. Okay, so that's plus. Now we have to subtract our first error term, and it will be, you know, Lego 1, this minus this, or again we can use the residual, it's fine, and we'll multiply it by MA1. Now we will also have, because we are forecasting March, we will go for March. So March minus March forecasted. Again, we can use this residual over here, multiply by this, but now we'll also add the previous error term to our model. So it will be so it will be the February error that we are going to adjust for our forecast. We are going to adjust our forecast for. So now we'll have to multiply these two. Oh, and again, I forgot some. Where did I forget my brackets? I don't know. Oh yeah, okay, here. That often happens to me. I often forget the brackets. Okay, and I did something wrong again. So let me just verify. Okay, so B27 plus B16 minus B15 plus B27 minus B26 minus B14 B15 B14 multiplied by O2 minus B27 minus C27 multiplied by M2 minus B16 minus C16 multiplied by N2 and plus B15 minus C15 multiplied by N multiplied by N. Interesting. I don't know why it happened. So give me one last second, and I will adjust for it. Okay, so our AR and M. So the previous period plus the seasonal difference, B16 minus B15, plus B27 minus B26, so the lag of 1 to forecast March, right? And subtract the difference between the periods, so B15 minus B14. Okay, so the February difference. Good. Multiplied by the AR component. And now we have to subtract error 1, B27, so February, the error of February. And we have to subtract the error of the previous period of 16. So if we are forecasting March, we have to take that error into account. So let me just do this first and let me see. Oh, okay, so that works. It works even well without that portion, I see. Does it work like this everywhere? Okay, so that's where it starts. Okay, so then here we will actually have to add our final portion, and the final portion will be plus the error of the previous period. So if this is April, we're going to add March. So for April, we're adding March. It will be B16 minus C16. Hopefully this time I'm not gonna miss it. Okay, so multiplied by this, and also I see that I didn't freeze them, so I will actually have to do it now. And let me just do it here. 2 M2, yes, and 2. Okay, and here it will be M2, and then 2. It seems that something doesn't want to work for me today. 17 minus 16, 20 minus C. Okay. So let's check out April, and that will be the last one that I'm checking out. Okay, so B16, B28 minus B27, B16 minus B15, perfect. So the ARIMA, the R component is good, the ARMA component. So minus B28 minus C28 by the first error term, and then minus B17 minus C17 multiplied by N, perfect. And we also have plus B16 minus C16 multiplied by both error terms. But maybe it's possible that this component is not important here. Oh yes, okay. So yeah, here it's not important. And then we can just continue this way. Okay, so I don't know, on one of the models that I ran, I actually needed to do it, so that's why, you know, I was trying to apply it, but I see that here it's not important, so we get it. And like our forecasts are good, are pretty good. So now all I have to do is just to change here these parts where I do not have the actual values anymore. And again, this one I could remove. I'm just gonna keep it, just, you know, because I'm lazy, but I could have removed it. And here, let me check. I think it will be the same thing. Yeah, so I have now to also create this one, change this one for C. And yes, that's pretty much it. Perfect. So now let's see how it works. Okay, so perfect. And here again, you know, it's just we have to go for it because that's our only option. And here again, so now we can remove more terms. So you see, the further we move away from the actual values, the less we can do, the less we can forecast. I mean, because now we didn't have any actual values anymore, you know, so we start using stuff that is not available, so we start relying on our forecasts more and more, and maybe that's not exactly perfect. It creates extra errors just because you know, we are moving away from the actual values that we could be relying on. So that's it. Finally it worked. Sorry about that confusion, but in the end I got it. So now that's perfect. And the model we again, I'm trying to save it. Why, I don't know. So again, our model was ARIMA and was 1 1 1, and then it was also 0 1 1 12. So this is a seasonal ARIMA that we ran, and that's how you should be using your coefficients to forecast values and to create pretty accurate forecasts. If we look at this model, you can see that it's the best of what we had so far. I do not look, you know, at different array terms. Definitely that will be something you should look at. You should compare the training and validation data sets between each other. I will show in R how to do it, but the R, actually it will be different, but this model was exactly what R selected. So that's like, since R selected that, you know, I tried different models and then I tried this one and it was the best one. And you can see it also by our residuals, how, like, by the symmetry of the histogram, by the QQ plot, by the correlations, by the white noise, I mean, you know, and you can definitely see that, yes, this is a good, reliable model, but now definitely you have to look at the error terms, and you can calculate them in Excel, you know, your MAPE and other errors.